Any questions?
Yeah, back in 2000, 2001, we did a study, and it's for the top deck of the west span, and we're going to cantilever the top deck out about 15 feet so on both sides, and that needs money, and they'll go back to the legislature, I guess, when the bridge is done. But right now, there's been another study that T.Y. Lin has been working on to bring that idea up to date. But to give you an idea, you come off the main east span, you go around the island, you go onto the west span, and you can go on either side of it now. And the reason that Caltrans is behind that is because it doesn't have any service platforms on the bridge. Like the Golden Gate, as you know, they can work on one side and not disrupt traffic, but not on the west span. So it's a win-win for both the bicycle people, pedestrians, and Caltrans.
Yes, you right there.
There's a NASHTO standard, and that's 4'6" for bikes. And the idea, it has to be higher than 3 feet or 3'6". 3'6" is what you get in residential projects, as you probably know. The other thing you get is a 4-inch space between the elements, pickets or horizontals. On a bridge under OSHTO, you can go 6 inches, but we chose to go 4 just because, as you know, in the Golden Gate Bridge at one time, a young boy, 2 years old, fell through, and it wasn't tight enough. So that's what's come up. And on the Golden Gate, the bike path rail is 4'6". It breaks into a curve at 4 feet, and the outside rail is at 4 feet. And I've worked on that suicide barrier and all that business out there in the bike rail. We designed it. So that's a good question.
It is very high, and I'm 6'3". I stand there, and it's about here on me. But it was, as Don said, it's based on a NASHTO standard. But it was all related to safety for bicyclists. You put somebody my height on a bicycle, and it was really related to safety, number one.
Okay, yes, right here.
It's cantilevered off the main viaduct, okay? And the thing to remember about pathways where people can gather, the load on that pathway can be greater than trucks and cars on the main span. And so it has to be well designed, and it was added on, but it was added on at a time when you could strengthen the deck, particularly the concrete viaduct. On the main span, the bicycle path there's ballast on the other side of the deck, so it can balance the weight if it is loaded. So that's a good question.
Yes, right here.
There's always some vibration on a bridge. In fact, a good example, again, is go over the Golden Gate Bridge and stand there, and you'll sense it. Suspension bridges are quite flexible, and they, when it gets hot or cold, it expands, and sometimes you can even hear them expanding if you listen carefully.
Yes, right there.
Two sort of design questions. One is, were there any considerations made for the sound of the bridge in terms of distance between concrete seams, things like that, as you drive over it? And also, what are some of the considerations that you guys have in terms of tying this bridge into the other bridge visually? Like, are we going to get the other side, the west side, is that going to get painted white also?
Well, let's start with sound. Do anyone?
Yeah, sound. We're using a surface on the bridge that will knock down some of the road noise. I mean, that's part of it. The exact composition on the main span, it's an acrylic plastic base, and then on the viaduct, it's concrete with a groove in it.
Yeah, I just add that yeah, sound was a big consideration, certainly because we have the bicycle pedestrian facility up there. It's referred to as tining, how you groove the concrete deck, so it's tined in a longitudinal direction, which would minimize the sound. If you've ever driven the Highway 80 up over the 580, 880, or 80 divide in North Berkeley, it gets very noisy as you ride up over the structures. It's because it's tined the opposite direction. So there was as much consideration as we could give to that challenge.
Another thing about it, if you ever go out to Yerba Buena Island and stand underneath the bridge, steel bridges like that with open members are very loud. There's a lot of expansion joints. The new bridge is segmental for the Skyway. It's broken into 4 frames, and so there are only 4 expansion joints. So a lot of the noise that you hear are the tires hitting the expansion joints, the vibration caused by the steel. So concrete structures are very quiet by their nature, and the main span also, as being a closed steel box, will be very quiet. So from below, it's going to be a lot quieter than the existing structure. So,
You know, and I'll keep it a little coy. For those of you that read Wired magazine or go to wired.com, be watching it for the next couple of weeks. You may see a Bay Bridge Sound story coming. The second part of that question was about tying in the bridge, and you guys addressed it, I thought, quite well in the presentation, but is there anything that you wanted to add about how do you create that connection on both sides?
No, the one thing we've done, and I mentioned it earlier, is the tower height to the new east span is roughly the same height as the west span towers. And we opened up the middle of it, so if you look at the west span towers, there's two legs and there's cross pieces in the middle, and if you look at 45 degrees, there's light between those two legs. And so the idea was to get some of that into the new tower, even though the scale's totally different. The idea was to light up the middle, you know, with natural light, and then light. You get the same thing at night.
I just emphasize what you said by, Michael, you talked earlier about the 17, if you will, criteria in the early design of the bridge, and that was one of the early criteria, that this bridge should be no taller than the west spans.
I mean, we'd like to see them paint the west span white, of course, but
Okay, right here.
Yeah, a question on the, probably for Michael. The fuses, effectively in a seismic event, there are fuses, I'm calling them fuses, from the top to the bottom, and there's 4 uprights. Effectively, how many of those can break away and the structure still be viable?
well, and Bart and Don might want to add to it. It's designed specifically that they can break and predictable where they're going to break. They're going to yield, you know, basically yield. They'll deflect, and the towers stay together. The tower won't separate, it won't break or anything like that. It's sort of like a shock absorber, if you will, that yields. And then after the seismic event, they can be unbolted and put back in. But the tower stays intact. Everything stays in place. There isn't really any change in basically the performance of it. And I'm pretty sure they're all designed to, I'm not exactly sure how many are designed to yield, but probably all of them are designed to yield.
yeah, they are at different levels of impact there. Another thing to remember is
Hydraulic rams or something?
no, they're just mild steel, and that it's not as strong as the steel that it's connected to. The other thing to remember, there are 5 hinges in the main viaduct, and those hinges have sliding pipes in them. One end is secured, and it's able to slide back and forth. And those are the clever plates you drive over when you're on the bridge beneath them. And inside those viaducts, there's extra beams, pipe beams they can put in if there's an earthquake.
So this is a really great question, and let me send you to a couple of other resources. First of all, baybridgeinfo.org actually has animations on how these different units perform, that you can see exactly how the shear link beams that were designed in the 4-legged tower for the self-anchored suspension bridge are designed to deform, bend, they can even crack. They were tested at scale in San Diego. And then hinge pipe beams also were designed in the deck of the bridge on the skyway. There are 20 of them in different locations. They are also designed to yield, to bend in a large-scale earthquake. You can also go to your local public library, look up Popular Mechanics, July 2007, and see a really great article on how these things work.
Thank you.
Yes, right there.
Lighting question regarding the path on the YBI transition structure. Westbound bicycle is heading for the island. Eastbound on-ramp with its illumination towers basically adjacent to the path just for the transition structure. Is there going to be glare in the face of a westbound bicycle?
Boy, that wasn't specific enough.
No, it's a great question. And I tell you, that's really an advantage of moving into the 21st century with LED lighting, is that when you look at one of our light fixtures, they're made up of a series of these LED elements within this 18-inch diameter. And each of these LED lights can be aimed specifically to light just the wash of the deck. So we're we have a lot of ability to deflect glare and to get the light where we want it. So I'm confident that glare is going to be at a minimum, but it's a great question.
Good question. Both of them are expected to take an earthquake of a magnitude you'd get in the next 1,500 years. And right now, the Golden Gate has been retrofitted on each end of each viaduct, and the main span is now being done. So in essence, to answer your question, they'll probably be equivalent, because when the law was passed in the state and the governor, he wanted those two bridges as life support bridges for the city, so they have to survive a magnitude of any kind of quake in the next 1,500 years.
But you should know that we actually created a new criteria for bridge building when we started the design work for the Bay Bridge. It's called Lifeline Criteria. We talked a lot about this in the first Joseph P. Nicoletti series, but basically this bridge had to be designed to be a lifeline to the region after a very large-scale earthquake. And it is the type of earthquake that would potentially damage the local international airports in Oakland and San Francisco such that airplanes couldn't land there. And so the type of quake that we've designed this bridge for, we would literally be flying supplies into Travis Air Force Base in Fairfield, trucking them down across the new Benicia Martinez Bridge, which was also built to this criteria, and taking them across these spans into San Francisco for the rebuilding effort. One of the things that, look, we know that this is not an if. We live in California. This is a when. This earthquake is going to happen. And one of the things that we've been committed to, Caltrans, the Metropolitan Transportation Commission, which is BATA on this job, and the California Transportation Commission, is getting this bridge done before the next big earthquake. Yes, right there.
How would the bridge respond to worst-case sea level rise over the next century?
You guys want to let me have that one? Okay, so honestly, I don't know how much exact design has been put towards that, but what we did do is most of, as you've seen in the design, most of the column supports are concrete, and there is a tremendous amount of steel inside that concrete. So we identified a section, and I don't know what the dimension is, that we call a splash zone. For potential sea level rise or a catastrophic event where you'd have a lot of water coming towards those columns. And all of the rebar that's inside that particular area for all of those different columns is coated in sort of a plastic coating so that it protects it from corrosion for over a long time. Yeah. Epoxy coat, thank you.
Yeah, in many cases, we put these pile caps below the surface of the water. So I'd say from a safety point of view, if the water goes above those pile caps, I think it's about 12 feet or something, you know, it still doesn't damage anything. So it's not aesthetic reasons, and they wanted them up there because they didn't want the ships to hit them. There are fenders around them where the passage is, but they can be under or above, and it doesn't affect any structural component.
That was an early design criteria as well, is that the pile caps extend above the height of the water. I'd add as well that I talked about the tree planting down the median of the Oakland touchdown to kind of define the beginning and end of the bridge. In the early design, we had a second row of trees because we wanted to reinforce that. But as we started to learn more about sea level rise as the design went on, we raised the riprap at the Oakland shore on that northern edge. So all the planting median, if you will, or medium went away.
Excellent questions. Any more? Yes, right here.
Where's the light rail part going to be?
Yeah, go ahead.
No, when we did the initial design, we did get a call from, I guess, MTC, because some of the public was asking the same question. So the bridge has been designed for light rail, not heavy rail, but to get it on there, you have to drop a lane of traffic. And we were on a peer review panel with OVARP and did a study of that near at the time when there's a lot of controversy. So it is planned for that, and hopefully there'll be less use of the car, and then they'll be able to do it. But it is planned for that.
And so the location for it, if you saw the self-anchored suspension bridge is one of the areas that dictates where it would need to be. It has to be on the inside lanes so that it can pass without having any problem with the cables that actually go across traffic. Yes, back there.
Are the overlook benches going to be double-sided, or are they only looking towards the water or only looking towards the cars?
No, that's a great question as well. When we designed the benches, there's always concern about, we have bicyclists up there on this path. It's a multi-use path. So there's actually On the bridge itself, there are no backs to the benches. You can face either direction. The idea is we didn't want to create, ideally you'd look out towards the water, not towards the roadway or the bicycle side, but the backs became an issue because they were very close to the edge of the bicycle path. So they're basically just a place to pause the rest for a few minutes and move on.
Thing we looked at on the benches was we didn't want them to get so close to the rail that somebody would get on top of that bench and sort of go over by mistake. So that was a very important part too. We had to pull them back.
Yes, right here.
Because of the media center San Francisco is and the sites, there are probably going to be some educational things eventually designed to go on that bridge with, you know, smartphone related things or tours, since there are all these vistas you talked about. Has there been any thought that you all have put into that?
Paul, did you plant this guy down here? Yes, there has. Can I take this one?
Oh, absolutely.
A communications question. Actually, yes. We've started a pilot. If you go to Yerba Buena Island and then go down towards Treasure Island, go through the gate, there's a California Street, your first right. It'll take you to the back. That's where you get that really dramatic view of the self-anchored suspension bridge. And we did almost exactly that. We put an informational sign there, sort of a kiosk that has a layout of the bridge, some call-out information, and some QR tags that will take you to different information. Basically testing to see how the idea would work, what the public would think about it for potential use in other locations. Clive, I'd also turn it over to you to talk about signage that we've been thinking about at Gateway Park and along the bike path.
Well, yeah, I didn't mention because we kind of rushed through the end of the presentation, but the bike path that terminates, I showed you in Gateway Park, part of the early design was that we continue the bike path into the East Bay and that it tied to the Bay Trail. Many of you may be aware there's such a thing as a Bay Trail that connects people to the Bay shoreline. So the piece of bridge that we built, the bike path and the bridge, really is a link in the Bay Trail. And then we're creating a connection then between Gateway Park, between the landing, and actually the bike path takes you over to about the location of IKEA in Emeryville, if you will.
Bart didn't tell you, but he's putting together a lovely package in the what he calls a sawtooth building. And as you go across the bridge, you'll see it. Maybe I took his story from him, but anyhow, but they're going to have the models you see out in the hallway. They're going to have all kinds of process in drawings and models, and there'll be pieces of the old bridge and things like that. But I'm sure Bart can fill you in on that one.
Yeah, well, we are still in development on that. Part of the idea for Gateway Park was to have a transportation gallery or museum there in the old, what we call the Irby's or Sawtooth building. It's a structure that used to service the key system trains that went across the bridge in the early days that it was open. We've held onto the building. It's a fantastic space, a lot of natural light, and so we're looking at how we can preserve that to tell the story of our Bay Area bridges and the Bay Bridge. Yes?
I'm assuming the on and off ramps on the east side of Yerba Buena will not be finished by Labor Day, this next Labor Day.
Yeah, there are quite a few areas that aren't going to be all the way complete. The bike path, even connecting down onto the island, isn't going to be complete because there's a conflict with the existing bridge. We're actually going to have to begin demolition of the cantilever span there right at Yerba Buena Island. There's a giant concrete pier that comes up that's literally right in the way of where those are going to be. So there will be some finished work that we do into the next few years to get the ramps where they need to be. There's also another project with the City and County of San Francisco to improve those ramps. Yes?
Any hope for people to actually ever bike all the way across?
Any hope of going all the way across with the bicycle coalitions that exist here? Well, I think you've heard a lot of that story of how the bike path came along, and there have been studies about what it would take, one quite a few years ago, one more recent. It's a very expensive endeavor right now. I think it was in the tune of $800,000 if we attempted to do it now. But there is coming 800 million. Oh, we just knocked that out for you, right?
80 million.
The decimal point. $800 million. But we are going to be looking at doing some further retrofit work, probably about 20 years out on the deck of the west spans, where it makes that a little bit more economical, more feasible to look at doing that.
Bart, it should be noted, and then we missed this, that the bike path on the new bridge is the first federal roadway that has any kind of pedestrian access.
Oh, good. Yeah. I-80. Excellent.
Okay.
Yes, way in the back there.
Last kind of going beyond the completion of the bridge, how long will it take to take down the old bridge?
How long will it take to take down the old bridge? You want me to-
I believe it's approximately 2 years. I mean, and the intent, I can tell you, the design team
It's
is
more than
already
that.
working on the demolition project design, and we intend, I can tell you, our lead engineer is planning the day we open the bridge next August. He's going to start tearing down the old bridge.
Okay, so don't start the clock on that one yet, because I don't. A lot of people, we all think we know that span out there, but believe me, it is bigger than you think. The first project that Clive is talking about, that's got that rough 2-year frame, is just the cantilever spans, massive bridge that connects us into Yerba Buena Island. I mean, if you think about just the lower deck of the Bay Bridge, it's 2 miles long and it's as tall as a 3-story building. This is much, much bigger than the original Carquinez Bridge that was taken down just a few years ago, and that took a little more than 2 years. But that first contract to get that part out of the way so that we can complete some of the assets that belong to the new bridge is roughly in that time frame. Then there are 2 other sections of bridge that will also be taken down. Yes?
I just have one question. So I realize that you're not going to have the off-ramps on the east side of Yerba Buena Island. Is there no access eastbound to the island then?
Oh, that's not true.
Okay.
It will be pretty much the same access.
Oh, it's okay. It's off on the left.
Right,
Correct.
right, exactly. And what I was mentioning before, and we're not really covering tonight, is that the city has got a project to upgrade these ramps and make them a little bit bigger. That's going to be coming online soon. Yes, right there.
I did notice that the piers holding the long stretch of the bridge seem fairly straightforward in terms of their shape and design, in contrast to the main tower. I was wondering if you can speak a little bit about to how they purposely are different, and they don't, like the towers actually has a silhouette, slender, and then it tapers.
Yeah, I
Sure.
think that it's economics is one of it. If to taper the piers is much more expensive than going straight up. And when you go much higher than that, we would taper them, but in this case, we didn't. But they pick up, like I mentioned earlier, the tower legs are on the corners of the pier, and the middle part of the piers are recessed, so that you get a similar breakdown visually as you get in the main tower. And that's the reason that they're that way.
If I can, I'll add to that too, just a little, because I've worked so close with you, Don. But as well on the Skyway piers, if you look at the top portion, which we didn't get into, you created kind of a negative space, a void across the top of the pier, such that the Skyway superstructure just floats along the top. And maybe you want to talk more about that, Don. But there was a lot of attention paid to the design of the
No,
Skyway.
I think just to bring it a little further, at the top that is a negative space, it's a cylinder, and the actual reinforcing in those edge conditions of the pier are cylinders, and we shaped on top of that structure, that reinforcing, we shaped this pentagon form, and that's the way we tied it in.
In the early phase, we looked at trying to poke holes in that. When Don was talking about the positive and negative spaces and those other things, you have to remember that's a seismic area, and those piers have tremendous forces in them. So we tried putting some holes in there, some openings and some other things, but the forces in there were so great that we basically, they needed to be very robust piers.
2 questions. Going back to the first question, it never was clear in my mind why the bike path was on the south side. Is it because that allowed you the connections at the ends? Because I would have thought that the more aesthetic place would have been to have it on the north side. The views would have been better there. And then my second question, you're driving westbound through the toll plaza. The road kind of swerves to the left, and then it swerves back to the right at the touchdown, and the bridge itself has a curve in it right there. Why wasn't that made straighter?
Okay, let's start with the bike path question. And Go ahead, Clive.
Yeah, I can start with the answer for your first question. The bike path's located on the south side, and I'd have to look to Bart a little bit here, but as I recall, certainly it was a budget constraint. It cost more money to build the bike path. There was a desire to build actually a bike path both on the north and the south so that the bridge was balanced. As Don mentioned earlier, once on the self-anchored suspension span, we had to provide counterweight system on the north side to balance that bike path to the south side. So ideally, we might have located the bike path to both sides, separated the users, westbound from eastbound, but it was decided to move it to the south for budgetary reasons, number one. Number two, there was a concern, you mentioned the views out to the north, and we didn't want to block views to the north for motorists. We don't want to block views to the south either. That's why we paid so much attention to the railing design to make it as transparent as possible. You also mentioned the landings. It was much more difficult to bring users off a bike path located on the north side of the bridge down to grade than it is on the south side, especially on Yerba Buena Island. But equally so in Oakland, because on the north shore, at the Emeryville Crescent, if you will, that's all wetlands and tidal action, and there was a desire to kind of maintain that clean, pristine, natural habitat.
Yeah. And when we had the path on both sides, the idea of Gateway Park had been around for a very long time. And so how would we get, it was a real big design problem because of the wetlands on the north side. How do you get people down to the south side and part of Gateway Park? We had looked at some designs. We had another bridges that went over top of the span and get everyone over. The soils on that side, on the north side, are really pretty bad. So it was really difficult to get people on that side, especially because all the activity was on the south side already, and also everyone wanted the views. This was really a bridge for Oakland and all those other things, and we wanted people to see Oakland. And Don was talking about the cranes and all of downtown Oakland and all those other things as well. And that viewpoint gave you the best views.
Yeah, we had, I guess, 4 or 5 sessions with the bicycle coalitions, and I mean, there didn't seem to be any problem by putting it on the south side. So they participated, and that's how it ended up.
Well, I would feel left out if I didn't comment. But more on the alignment thing. What we have happening right now is a temporary alignment that we had to put in place because the way that the bridge was originally designed, the way the project was originally designed, the westbound side heading into San Francisco was going to be opening up about 9 months to a year before the eastbound side because there was part of the original bridge. The elevated roadway that you drive up on right now to go towards San Francisco is in the way of the new eastbound alignment. So what we were going to have to do is open westbound, move traffic off that, demolish that structure, and then connect the eastbound side. But our engineers came up with an idea that if we added structure onto the existing bridge there to the south a little bit, we could skew, kind of move over to the side, eastbound traffic, so it's out of the way, and then we could also move westbound traffic over on this new structure, and we could surgically remove the piece of bridge that was in the way, and we could put a construction team there in between the new bridge and the existing bridge and build out that eastbound connector and open the entire bridge at once. So we did that. We made that skew so that we could move traffic out of the way. We did that surgery, took that part of the bridge off with traffic running on it. And right now we have FCI out there building out the eastbound side. That's the reason why the whole bridge can be opened at once.
And Bart, it's also a couple months earlier by doing it that way.
9, yeah, we bought like 9 months back. But yes, you follow up.
The touchdown on the east end, it curves. Why wasn't that simply made straight? You would have had a more direct path to the toll plaza. Instead, it turns to the south. Well, if you're coming from the toll plaza, so as you're looking as you'd be driving,
right,
it swerves to the left, and then as you actually get to the bridge, it swerves back to the right, and the touchdown itself is curved. Why couldn't that have been made straight?
Yeah.
Bart, it's a great question. I think number one, if you provided a straight line connection, I guess it added to the length of the bridge. I think you'll have number one, so it probably increased cost. And the other thing you'd have to talk about was the foundations. I know we founded the bridge at that end as you know, as ideally as possible on strong material, but it's more a question for our engineers part. I'm not sure.
And one you need a map for.
In the ultimate configuration, it's going to be straight, you know, when all the temporary things are done. And in fact, on the north side, because the soils are so bad, they went out and started compacting soil, like a year ago or something, and getting the soils all ready for that. And so in the final configuration, it's going to be much more straight than it is right now. Right now, is like the tie into Yerba Buena Island, that's a temporary condition with the curves.
No, the new touchdown has a curve in it too.
No, you're right. That's right.
It definitely has to do with the way that the bridge is situated. It's something that would be better explained with a map. But if you look as you go across right now, you can see the asphalt that's out there, sort of just waiting to make the connection. Sure.
Come to the next lecture series, and we'll answer your question.
Okay. Yes.
Yeah, is it true that the piles on the old bridge, are they friction-driven wooden piles? They are.
Yeah.
What condition are they in?
What I gather, they're okay. They're only 90 feet deep, so.
Well, the condition is actually pretty good, and they were the deepest piles of their day. But that one of the reasons why we ended up building a new bridge was that all of those foundations would have needed to be completely replaced if we retrofitted the existing bridge. And anything is possible, but we would have been looking at trying to find a way to support the bridge with traffic on it and replacing those wooden pile foundations. But when they were examined, they were in decent shape. Yes?
Changeable message signs, change sign clutter. How are you avoiding that on this bridge? Is that going to be one of the surprises that we see when you open, is suddenly there's 6 or 8 different LED signs?
It's CMS sign evolution.
Well, I'll try and answer that, but I mean, certainly I'm involved in the visual experience of the bridge. Signage is a big consideration. In fact, there was an earlier question about what type of signage are we providing on the bike path. I don't think I answered that, but we are providing interpretive signage along the bike path. This doesn't answer your question, but just like you go to a national park or the state park system, it'll explain things along the way on the bridge. As far as the signage on the bridge itself, certainly we need changeable message signs. We have traffic signs. We've worked and integrated those sign structures into the design of the bridge, meaning they're white, they're pentagonal in form. But we're trying to avoid sign clutter as much as possible. My bigger concern is probably on the bike path, because we have a lot of rules and regulations that come out on bike paths. You know, dogs, no dogs, skateboards, no skateboards, stay right. I mean, when you start looking at all the considerations that go into the users on this bike path, I'm more concerned about signage on the bike path than on the roadway itself. But we're working towards a goal that will minimize that.
Yeah, I think Clive didn't mention, but we have been working with the signs to try to get them all in one vocabulary. We use the toll plaza signage that you'll see eventually, and it's sort of a black surface, and then behind it there's some neons, in essence, or LEDs that will tell you what's going on, and that'll carry through the bridge itself for the ones that cantilever over the roadway. And they come off a white pole. Most of the structure will be white, but all the elements will have this black screen that'll, like you'll see in the toll plaza.
Well, gentlemen, it's getting to be about 8:30. This has been insanely fun chatting with you guys. Again, we want to thank our hosts at the Aquarium of the Bay before they get their hooks out. But before you clap, one last really great question. Who's got it? Let's have one last one to end on. Oh, where? Where is it? Is it right? It's right there? Okay, yes.
I was there when the Golden Gate Bridge Authority was thinking about double-decking it, and I talked against it. And today we have a problem with the fact that the paint on the Golden Gate Bridge is now rusting away the bridge. And what kind of paint are you going to be using so it won't rust away this bridge?
Well, like I mentioned earlier, the white paint we're using has been tested on the the white cranes of Oakland, and it's supposed to have like a 10 to 20-year life, but that's something else. But I haven't heard, I've worked on the Golden Gate Bridge for 20-plus years, and I haven't heard that fact that it's rust. Oh, no, it's, I mean, there's been rust out there, and they sandblast it off and repaint it. But the,
I can add.
okay.
Add just a little to your, or try and answer your question, that the paint is called polysiloxane paint. I don't want to, we have a department in Sacramento that just deals with coatings, so we recognize that issue as a real important issue. So we worked with, if you will, our experts up in Sacramento to come up with the best coating possible. Much of the bridge components are galvanized first before they're painted, so we expect the system to last a long time.
How do you say that, Clive?
Polysiloxane.
Polysiloxane paint.
I don't think I can say it again.
Okay, so let me add to that we use most of the eastern span of the Bay Bridge, 1.2 miles of it is basically a concrete structure, one that we're not going to have to paint. And a good reason for that is that all of that distance is not something that we're going to have to maintain because it doesn't have the same steel. The bike and pedestrian path that cantilevers off of it is steel. There are maintenance travelers that are going to hang out there, and we are going to have to service that as well as a self-anchored suspension bridge. But if you're really into this, go to baybridgeinfo.org, click on our Webby Award-winning Bay Bridge 360, and watch our video called The War on Corrosion. Thank you, everybody, for coming out tonight. We'll see you in a month.